Assalamu alaikum wa rahmatullah. Dear students, in the previous lecture we have started new unit from the physical chemistry that is surface chemistry. In that very lecture we have just defined what is surface chemistry. We can repeat the definition again. It is the branch of the chemistry which deals with the study of phenomena occurring at the surface or on the interface. We have discussed these things. And in this very unit, we have to discuss three important topics. The first one we have started, that is adsorption. Remember this point. This is the first topic, very important topic. We have started it already in the previous lecture. What is adsorption? Definitions of adsorption. And you can remember the simplest definition. It is accumulation of the particles, molecules of a substance on adsorbent surface. Concentration or accumulation of molecules of a substance on the adsorbent surface. Then two things in adsorption, two things are being involved. There are two terms, that is adsorbate and the adsorbent. We have discussed the substance which get accumulated, that is adsorbate, and the substance on which accumulation takes place. For example, we have dust particles, they stick on the surface, board surface, it is adsorbent, and the dust particles, they are adsorbate. I don't know. Then we have discussed desorption. If you remove the adsorbate from the adsorbent, the reverse process, that is known as desorption. Remember this point. Then we have distinguished two terms, adsorption and absorption. Remember this point. We have already discussed it. Adsorption and we have absorption. When the adsorbate particles remain on the surface, that at that time it is adsorption. But when they enter into the bulk, into the whole body of the adsorbent, at that time it is absorption. Remember this point. For example, if you have this adsorbent surface, this is adsorbent. If the adsorbate particles remain on the surface, it will be adsorption. It will be adsorption. But if the adsorbate particles, they enter into the bulk, into the whole body of the adsorbent, at that time it is absorption. It means that it is adsorption when the adsorbate particles remain on the surface, and when they enter uniformly, distribution is there, at that time it is absorption. Sometimes what happens, both the processes takes place simultaneously. When both the processes, adsorption is followed by absorption. First they remain on the surface, then the adsorbate particles, they enter into the bulk. It means that adsorption is followed by absorption. When both the processes takes place simultaneously, at that time the term is sorption. You have to remember another important term. We are discussing the terms involved in the adsorption. We have sorption. This term was introduced by McBain. You have to mention this term was introduced by McBain. This is the first point. Sorption term was introduced by McBain. And how you can define the sorption? When both the processes, that is adsorption and absorption. These are the two terms, these are the two processes. When both the processes, adsorption and absorption, takes place simultaneously. You have to remember this point. When both the processes, adsorption and absorption, they takes place simultaneously, at that time you can remember also adsorption is followed by, first the adsorbate particles, they remain on the surface, that is adsorption. Then they enter into the bulk. At that time there is absorption. It means that absorption is followed by absorption. Adsorption is followed by absorption. Adsorption is followed by absorption. At that time the process is known as sorption. At that time the process is known as sorption. You have to mention this. This term was introduced by McBain. This is the first point, and how you can define the sorption when both the processes takes place simultaneously. Adsorption is followed by absorption. At that time, it is known as sorption. You have to mention this definition. We can draw the projection. I have already mentioned, if you have the adsorbent surface, if the adsorbate particles they remain on the surface, it will be adsorption. It will be adsorption. If the adsorbate particles penetrate the surface and enter into the whole body, enter into the bulk of the adsorbent, at that time it will be absorption. At that time it will be absorption. Now, what happens in the sorption? The particles, they get first adsorbed on the surface, then they also enter into the bulk. It means that both the processes takes place. It will be sorption. Sorption. You can draw these projections. This is adsorption, this is absorption, and this is sorption. Remember this one. Now we have another important term you have to mention: positive and negative adsorptions. Positive and negative adsorptions. Positive and negative adsorptions. In both the cases, adsorption process is there, but there are two important differences. There are difference between these two, positive and negative. For example, if the concentration of the adsorbate is more on the surface than in the bulk. This is the way. When the concentration of the adsorbate is more on the surface than in the bulk, at that time it's positive adsorption. It is positive adsorption. At that time it is positive adsorption. If reverse thing happens, concentration of the adsorbate molecules is more in the bulk than on the surface. You will find here the concentration of the adsorbate particle is more in the bulk than on the surface. At that time it will be negative adsorption. Negative adsorption. Remember this point. Negative, positive and negative adsorptions. Positive and negative adsorptions. You can say when the concentration, you can mention this line, when the concentration of adsorbate particles is more on the surface than in the bulk. At that time it is known as this one. At that time it is known as positive. At that time it is known as positive adsorption. At that time it is known as positive adsorption. At that time it is known as positive adsorption. But the reverse thing happens. But when the concentration of adsorbate particles is more in the bulk than on the surface of adsorbent, at the time it is known as negative adsorption. You can mention these two terms, positive and negative adsorptions. It means that we have adsorbate, we have adsorbent, we have adsorption process, we have desorption process, we have occlusion. When the gas particles get adsorbed on the metal surface, the term is occlusion. We have sorption. We have positive and negative adsorptions. I will take example of Softshell. Where both the processes takes place. You can mention the first example of Softshell, dye particles. When we go for dyeing, coloring the cloth, what happens? Dye particles get first adsorbed on the surface. Then the dye particles enter into the bulk of the cloth. It means that during dyeing of the cloth, both the processes takes place. First adsorption, then they enter into the bulk. It means that sorption process takes place. You can mention the first example, dye particles first get adsorbed on the cloth, on the cotton cloth, on the cotton fabric. Dye particles first get adsorbed on the cotton fabric and then enters into the bulk of the cloth. Dye particles first get adsorbed on the cotton fabric, then first the particles remain on the surface and then enters into the bulk of the cloth. It means that it is absorption. When it enters into the bulk of the cloth, it is absorption. It means that both the processes, that is adsorption followed by absorption, it means that both the processes takes place. Hence, it is an example of sorption. Remember this point. I will take another example from your text. When hydrogen H2 gas comes in contact with charcoal, it gets adsorbed on the surface. Then what happens? First there is adsorption, then the gas molecules enters into bulk of charcoal. When it enters into the bulk of charcoal, it means there will be absorption. There is First there is adsorption, then the hydrogen gas, they enter into the bulk. It means there is absorption. You can mention it. Charcoal adsorbs as well as absorbs hydrogen gas. You can mention it. Charcoal adsorbs. Charcoal adsorbs as well as absorbs hydrogen gas. You can mention it. Remember this one. It means that sorption means when both the processes takes place. Adsorption is followed by absorption. At that time it is known as sorption. You can mention dyeing. The dye particles first get adsorbed on the surface, then they enter into the bulk of the cloth. It means that dyeing is an example of sorption. You can also take the example of hydrogen gas and charcoal. Hydrogen gas first get adsorbed on the charcoal, then it enters into the bulk. It means that sorption process takes place. Now we will discuss how this adsorption process takes place. What is the mechanism of adsorption? Mechanism of adsorption. Mechanism of adsorption. Mechanism of adsorption is due to surface tension. You have already discussed the surface tension in the 11th class. If you consider a liquid, you have learned that the surface molecules are in different behavior than the bulk molecules. If you have a bulk molecule, the bulk molecule is attracted by other molecules in all the directions. Hence the net force acting on it is zero. If you consider the bulk molecule, this is the situation. This is the case of bulk molecule. The bulk molecule is being attracted by other molecules in all the directions. Hence the net force acting on it is zero. If you consider the molecule on the surface, there are interactions, attraction, interior attractions only. This is the situation. It means that the surface molecule, it is being attracted by the interior molecules, hence it experiences a downward pull, and that downward pull is termed as surface tension. It means that because of this downward pull, the surface molecule experiences a tension. That tension is known as surface tension. If you consider the case of, this is the case of liquid. If you consider the case of solid, same thing happens. If you have a bulk molecule, it is being attracted by other molecules in all the directions. Hence the net force acting on this bulk molecule, it is zero. This is the case. And in the same way, just like in case of liquid, the surface molecule, it feels some downward pull, some downward force. This downward force, it is known as unbalanced force. Unbalanced force. Force is not balanced. In the interior case, in the bulk molecule, in case of bulk molecule, the force is balanced, but here the force is unbalanced, or this unbalanced force is known as a residual force. This unbalanced force or residual force, it is in case of both liquid and it is also in case of a solid. In both the cases there is this unbalanced or residual force. Now if you take the case of a metal, for example, you have nickel crystal. Same thing happens here also in case of metal crystals. The atoms which lie in the interior of the crystal, they have satisfied valencies. Let us consider this one. They have satisfied valencies. If you consider this is a satisfied valency, but if you consider the surface nickel atoms, they have unsatisfied valencies. Unsatisfied valence, it means that these have tendency to form the more bonds. Valencies are not satisfied, valencies are unsatisfied. You can say it is the case of nickel crystal, the surface atoms have unsatisfied valencies. Unsatisfied valencies. I can show here this one. It has unsatisfied valency. Now you can remember, because of unbalanced or residual force, or because of satisfied, you can mention unsatisfied valencies, adsorption process takes place. The surface molecules have tendency to attract. The surface molecules try to become stable. How they become stable? They try to decrease this residual force. They try to decrease this unbalanced force. They try to form the bond. When they try to form the bond, for this they try to attract and retain the adsorbate molecules. It means that because of this unbalanced or residual force, or because of unsatisfied valencies, the surface of adsorbent, this is the adsorbent, these are the three examples of adsorbent. The surface of adsorbent has tendency to attract and retain the molecules of adsorbate on the surface. That is, because of the unbalanced or residual force, the adsorption process takes place. You can draw these three. This is the case of liquid, this is the case of solid, this is the case of nickel crystal. You don't have to mention, you have to remember the interior molecule is being, the bulk molecule is being attracted by other molecules in all the direction. You have learned these things in the 11th class. And as the net force acting on the bulk molecule, it is zero, but the molecule present on the surface, it feels downward pull. As a result, the force is unbalanced or residual force. It is the case of solid, and this is the case of nickel crystal. And because of this unbalanced or residual force, adsorption process takes place. What is the mechanism? Why the adsorption process takes place? For this unbalanced or residual force, or for this unsatisfied valencies. You can mention this very important point. Why the adsorption process takes place? You can mention due to the unbalanced force. You can also mention it is the residual force. Due to the unbalanced force or unsatisfied valencies. Unsatisfied valencies due to the unbalanced force. It is also known as residual force or unsatisfied valencies on the surface, the adsorbent surface attracts. First thing, it attracts, then it retains, attracts and then retains the molecules of a substance, molecules of adsorbate, molecules of adsorbate. You can mention adsorbate. Due to the unbalanced or residual force or unsatisfied valencies on the surface, the adsorbent surface attracts and then retains the molecules of adsorbate. That is, adsorption process takes place. Adsorption process takes place. You have to mention why adsorption process takes place. Because of unbalanced or residual force or unsatisfied valencies, adsorption process takes place. You have to mention it. Adsorption process takes place. Now we'll discuss an important point here in mechanism of adsorption. We'll discuss important point, enthalpy and enthalpy and entropy changes. Enthalpy and entropy changes during adsorption. During adsorption. During enthalpy and entropy changes during adsorption process. During adsorption. When adsorption takes place, what happens to enthalpy? I will mention here enthalpy change means delta H. You have to mention delta H above the enthalpy. Remember this one. What is entropy? You can mention here small, it is delta H. What happens to the delta H? What happens to the delta H during the adsorption process, or you can say spontaneity. Spontaneity of adsorption. Whether the adsorption process is spontaneous, whether it takes place or it does not take place, on this point, spontaneity of adsorption process. Whether it takes place at its own, whether it is spontaneous or not, we will discuss it in terms of delta H and delta S. This is a very important topic in the mechanism, enthalpy and entropy changes during the adsorption. We will discuss it. Dear students, when adsorption process takes place, for example, you have the nickel crystal. There are unsatisfied valencies. When adsorption process takes place, what happens during adsorption? Interaction occurs between the nickel surface atoms and the adsorbate. There is interaction. During interaction, what happens? The valency of nickel gets satisfied. It means that during adsorption, there is interaction between the adsorbent molecules, surface molecules, and the adsorbate. Let us say these are adsorbate. There occurs interaction, there occurs bond formation. Either weak or strong, we have to discuss in the types of adsorption. But interaction occurs there, and because of this interaction, what happens? Energy gets released. This is the first point you have to mention. Whenever there is adsorption process, interaction occurs between the adsorbent surface molecules and the adsorbate molecules. Interaction takes place, valency is being satisfied. What happens because of that? Energy gets released. When energy gets released, you can say the surface energy gets decreased. The energy, unstability on the surface. Unstability means high energy. When unstability gets decreased, it means that surface energy, this is a very important point, surface energy gets decreased. Surface energy gets decreased. How the surface energy gets decreased? You have to mention if there are no adsorbate molecules. These are unstable, they have high energy, they are highly energetic. They want to become stable. They undergo interaction with the adsorbate molecules. When there is interaction, either van der Waals or the strong interaction is there. What happens? Energy gets released. When energy gets released, you can say two things here. The valencies get satisfied. Stability comes on the nickel, on the surface of nickel. And what happens? Energy gets decreased, and we can say surface energy, the energy on the surface energy gets decreased. It means that during adsorption process, you have to remember, surface energy gets decreased. You can also mention if you have this liquid, same thing happens here. Surface molecule, it is unstable because of downward pull, because of surface tension, you know it. And then adsorption process takes place. When adsorption process takes place, now we have molecules on the upper side also. If there is no adsorption, what happens? There are molecules only in the interior, in the bulk of the liquid. But when there is adsorption, now there will be molecules on the upper side also. What happens? The unbalanced force, residual force gets decreased. Because now we have the molecules from the upper side also. Now the unbalanced or residual force gets decreased. Or you can also mention here, just like this one, the energy of the surface layer gets decreased. You can say surface energy gets decreased. Decreased surface energy gets decreased, which comes out in the form of heat. The surface energy gets decreased. What it means is that energy comes out in the form of heat. That is known as heat of adsorption. That is known as heat of adsorption. That is known as heat of adsorption. What is meant by heat of adsorption? The surface energy gets decreased because of adsorption. When there is adsorption process, you can take the example of nickel surface, you can take the example of liquid. In both the cases, unbalanced force gets decreased, residual force gets decreased, or you can simply say during adsorption, surface energy, the energy on the surface layer gets decreased, which comes out in the form of heat. That is known as heat of adsorption, and heat of adsorption is represented by delta H. That is energy, it comes out. Hence you can say delta H, it gets released, energy gets released. You can say delta H, it is negative. We have discussed two things, delta H change during the adsorption process. The first point, it is clear, during the adsorption process, what happens? Enthalpy change, enthalpy of adsorption. You can say heat of adsorption, or you can say enthalpy of adsorption. Enthalpy of adsorption. Enthalpy of adsorption, that is delta H, it is negative. It indicates that during adsorption process, energy gets released, energy gets liberated, that is delta H, it is negative. First, we will mention this point. You have to remember, during the adsorption process, the valencies get satisfied, or you can say residual or unbalanced force gets decreased. As a result, surface energy gets decreases, which comes out in the form of heat, which is known as enthalpy of adsorption or heat of adsorption, or you can say during adsorption, energy gets released, hence delta H, it is negative. This is the explanation. What happens to the delta H during the adsorption? It becomes negative, it comes out to be negative. You can mention this. What happens during the adsorption? During adsorption, this is the first point you have to mention. During adsorption, the residual force, or you can say unbalanced force, gets decreased. Residual force or unbalanced force gets decreased, which leads to a decrease in surface energy, which in turn comes out in the form of heat, It means that heat is being generated, heat comes out. That heat which comes out, that is known as enthalpy of adsorption, or heat of adsorption. Surface energy comes out in the form of heat, which is known as enthalpy of adsorption or heat of adsorption. In other words, you can say, we can say adsorption process. Adsorption process is accompanied by release of energy. You have to mention it. What is meant by release of energy? This is the point you have to mention. Delta H, it is negative. This is the first point you have to mention. During adsorption process, enthalpy delta H, it comes out, heat comes out, hence it is negative. Now we will see the entropy change. This was the effect on delta H during the adsorption. Delta H is negative. You can mention here, during adsorption, delta H, it is negative. Now we will see the entropy change. During adsorption, what happens? For example, if you have the adsorbent surface, this is the adsorbent surface, and we have the gas particles, they are gas molecules, adsorbate molecules, they are randomly, they are free. But when adsorption process takes place, what happens? Their randomness gets decreased. Now they get attached, they get bound with the adsorbent surface. It means that the randomness of the adsorbate particles get decreased. When the randomness decreases, it means that entropy will also decrease. Entropy, randomness, entropy is a measure of randomness. Greater the randomness, greater will be entropy. But when there is adsorption, what happens? Randomness gets decreased, which leads to decrease in entropy change. You can say entropy decreases. When entropy decreases, what it means? That it means delta S, entropy change, it will be also negative. It means that adsorption process is accompanied by decrease in enthalpy as well as decrease in entropy. Delta H is negative, delta S is also negative. You can mention it during adsorption. During adsorption, this is the second point in the mechanism you have to mention. During adsorption, the randomness of adsorbate particles, randomness of adsorbate particles gets decreases, which in turn leads to decrease in entropy, that is delta S is also negative. Now you can summarize, you can sum up these two. In general, you can say an adsorption process is accompanied by decrease in enthalpy and decrease in entropy. In general, we can say, this is the point you have to mention, we can say adsorption process leads to a decrease in enthalpy, that is delta H, and decrease in entropy. You can mention during adsorption what is the effect on delta H, that is negative. What is the effect on entropy, that is also negative. Decrease in entropy, you can underline this point. Decrease in enthalpy and decrease in entropy. Now you have to understand whether the adsorption process is spontaneous or not. First we have to mention delta H change, it is minus. Delta S entropy change, that is also minus. To predict the spontaneity of a process, whether a process is spontaneous or not, you have to mention Gibbs free energy delta G. We have discussed this Gibbs free energy in thermodynamics in 11th class, delta G, which is equal to delta H minus T del S. Remember this point. For a process to be spontaneous, remember this point, you have to determine the spontaneity of a process, whether it will take place or not, whether it is spontaneous or not. You have to mention, you have to study delta G, Gibbs free energy delta G, which in turn is equal to delta H and minus T del S. Remember this one. For a process to be spontaneous, we have discussed this already. You can remember, no need to mention, but you can remember, for a process to be spontaneous, delta G must be negative. When delta G comes out negative, the process is known as spontaneous process. The process will be spontaneous. If delta G is positive, process will be non-spontaneous. You know these things. If delta G comes out to be 0, at that time there will be equilibrium. Three things are there. If delta G negative, we have discussed it in a detailed manner in thermodynamics. The spontaneity of a process is determined in terms of Gibbs free energy dash delta G. For a process to be spontaneous, delta G must be negative. If it is positive, then non-spontaneous, and if it is 0, then it is equilibrium. But here it is clear, delta G depends upon delta H and del S. Delta G and delta H and delta S. It also depends upon the temperature, remember this point. But here it mainly depends upon delta H and delta S, remember this point. Now we will see under which condition it will be negative. Under which condition this delta G will be negative, the process will be spontaneous. Here what is clear? During adsorption, delta H is negative, delta S is negative. If you compare these two, for example, delta H is negative. This is the way. Minus sign. Now you can consider T del S. If del S it is also negative, it means that this will be negative term. This you can have minus, negative, minus, it is plus. Now the question arises whether minus will dominate or plus will dominate. Remember this point. It will depend upon if for the negative value of delta G, this delta H minus negative part, it should dominate. I will give an example. For example, if you have delta H minus 20, let us say minus 20, it is the formula minus. It is also minus delta S, it is also minus, you can say this term is minus 10. It means that it is negative, but enthalpy delta H is sufficiently negative. It means minus 20 means greater amount of energy gets released. Here only minus 10. Let us say minus 20 kilojoules of energy gets released. Here it means minus 10 kilojoules of energy gets released. It is clear that in this case greater amount of energy gets released. Minus, it is minus here. What it means? Minus 20 minus plus, it is 10. Now if you solve it, you will have minus 10. The sign will be negative. It means that although both are sinus, for a process to be spontaneous, for the spontaneity of adsorption, delta H should have sufficiently high negative value. Its negative value should be high. It should dominate to the value of delta S. It should have greater negative value. It is negative, it is also negative, but the negative at delta H should have greater negative, should have sufficiently negative value than the delta S. At that time, the overall sign will be minus. When the overall sign is minus, at that time delta G is minus. When delta G is minus, the adsorption process will be spontaneous. This is the only condition. Both are minus, but delta H should have sufficiently high negative value as compared to the delta S. Remember this point, you can mention. This is a very simple explanation how you can say whether the adsorption process is spontaneous or not. Both are negative, but delta S should have sufficiently high negative value as compared to the delta S. You can mention this now. This is the important point. For a process, the spontaneity of a process is determined in terms of Gibbs free energy delta G. The spontaneity of a process is determined in terms of delta G. For a process to be spontaneous, you can mention here, for a process to be spontaneous, delta G should be negative. For a process to be spontaneous, delta G must be negative. Remember this point. For a process to be spontaneous, delta G must be negative here. Now we can say for the negative value of delta G, now you know here delta G is negative, delta S is also negative. What should have? Delta H should have sufficiently high negative value than the delta S. You can see, you can mention this point for the negative value. This is the line you have to mention for the negative value of delta G. This is the line you have to mention for the negative value of delta G. Delta H should have sufficiently high negative value. Should have sufficiently high negative value. Should have sufficiently high negative value as T del S is positive. Should have a sufficiently high negative value as that of delta S. You can say T del S as that of T del S. When delta H has sufficiently high negative value, then overall delta G becomes negative and the process will be spontaneous. These are some thermodynamic condition changes, thermodynamic changes during adsorption. Delta H is negative, delta S is negative. Remember this point, for a process to be spontaneous, delta G must be negative. For negative value, what is the condition? Delta S should have sufficiently high negative value as that of T del S. When it has lower value, for example, you have, I will repeat it again, delta G is equal to, it is negative, let us say minus 20. Let us say minus 20, then formula minus, if T del S has lower value of less value, negative value, this is the way, minus 20, it is plus 10, the overall sign will be minus, the process will be spontaneous. It means that for the spontaneous process, for the spontaneity of adsorption, delta H, it means tremendous amount of energy should get released. That is, delta H should have sufficiently high negative value as that of T del S. Now, what happens during the adsorption process? Last point, in case of mechanism, you have to mention this is a very important topic. You have to mention this very important topic, important point. Dear students, when adsorption process takes place, first all the sites are unsatisfied. All the sites are unsatisfied. It means that tremendous adsorption process will be greater, there will be greater adsorption and tremendous amount of energy gets released. It means that initially tremendous amount of energy gets released, but with the passage of time, kal bhi humne bola hai, yesterday we have discussed it, with the passage of time, when some sites have been satisfied, now the amount of energy gets decreased. It means initially delta H, it has sufficiently high negative value because tremendous amount of energy gets, because all the sites are free, adsorption rate will be high, tremendous amount of energy gets released. When tremendous amount of energy gets released, it means that delta H will have sufficiently high negative value. But as the process occurs, as the adsorption process takes place, what happens, dear students? Now the energy releases, but it releases to a smaller extent. It means that delta H will become less and less negative. Will become less and less negative. Less and less negative. Well, during when the adsorption process takes place, delta H becomes less and less negative. Finally, a stage reaches. For example, delta H हमने भी बोला minus 20. Delta S हमने बोला था minus 10. But when the adsorption process takes place, its value will decrease. Minus value will decrease. It will become minus 18. It will become minus 15. It will become minus 12. It will become minus. Then finally a stage will reach when its value becomes equal to the value of delta S. It means that initially the process is spontaneous. initially adsorption process is supreme, but when as the adsorption process takes place, delta H becomes less and less negative. It means that initially tremendous amount of energy gets released because all the sites are free, but as the adsorption process takes place, less and less amount of energy gets released, delta H will become less and less negative. Finally, a stage will reach when delta H and del S, finally its value will decrease to minus 18, then minus 15, finally a stage will reach when delta H is equal to delta S. When these two terms become equal, for example, delta G is equal to minus 10, minus, it is also minus 10. What will happen? Minus 10 minus plus 10, it will cancel. Delta G will be 0. I have already mentioned when delta G is 0, this process will attain equilibrium stage around this point. It means that as the adsorption process takes place, delta H becomes less and less negative. Finally, a stage will reach when delta H and delta S become equal. When they become equal, delta G will come out to 0. When delta G comes out to 0, it means that equilibrium state has been attained. You have to mention this very important point. When the adsorption process proceeds, the delta H, this is the point you have to mention, becomes less and less negative. Finally, a stage reaches. What is that stage? When delta H becomes equal to delta S. At that time, what will happen? At that time, delta G will come equal to 0. When delta G comes equal to 0, this will be the stage of equilibrium. This will be the state of equilibrium. Delta G is equal to 0. What it means? This is the state of equilibrium, and this equilibrium is known as adsorption equilibrium. It means when equilibrium is attained in adsorption process, it is known as adsorption equilibrium. You have to mention, initially the adsorption is spontaneous, but when it proceeds, what happens? A stage will reach when there is equilibrium. It means that number of particles which get adsorbed, it will be equal to number of particles which leave the surface which get dissolved. There will be two processes, adsorption and desorption. At that time, delta G is equal to 0. This was about the mechanism, how the adsorption process takes place. And in the next lecture, inshallah, we discuss important topic, factors affecting adsorption of gases on solids. Inshallah, we discuss this very topic in the next lecture. Till then, fi amanillah.